Sweet, welcome in everyone. Thank you for a couple song recommendations here. Always looking for those. I did just add it like that because I trust your music recommendations, but also if I don't like it, I'll just take it out the playlist, so it's all good. Um, let's get going here. So today's problem, we've got group anagrams. This is Blind 75 Day 4, I think. It's in the title of this stage. Yes, Day 4. And let's take a look. Yeah, don't need much preface here. Okay, group anagrams says given an array of strings called strs, we're going to group all anagrams together into sublists. So we're going to have a list of lists when we're done. You may return the output in any order, so it's not like we have to have a certain anagram or a certain string first or within the lists. They don't need to be ordered in any particular way. Ooh. Got you your offer for last summer, so clearly a question that can be asked. So we'll diagram this as well in a sec, but let's just take a look quickly at the examples. So hopefully by looking at this, you can identify a few anagrams just by sight. Remember, anagram means that the two strings you're comparing with each other have the same letters at the same frequencies, but maybe different orders. So for example, act and cat would be anagrams here, and you can see they show up in this sublist right here. Pots, tops, stop are all anagrams, and they show up in this sublist right here. And then the final word hat, nice. The final word hat here is in its own sublist, so it has no anagram partners, but it is its own list because it is one of the words in strings here. And the overall structure here is that we have an outer list and within a bunch of inner lists that have strings that are anagrams of each other. You can see the next one is just one single list, and so we return a list of lists, but it's just one list internally. Okay, and then the final one, we've got the empty string, which is a string, so that belongs in its own list within the larger list. So it's possible to have a list of just a single list. They give us some more specific constraints here. The length of strings, and this is the array that we're given, will be between 1 and 1,000, so there will be at least one string present in the list and up to 1,000. Strings at i.length, so the length of an individual string might be anywhere from 0 to 100. And then the strings we're provided will only be comprised of lowercase English letters, so we don't have to worry about weird symbols or anything like that. Okay, let's do a little diagramming here. We'll use this first list. I'll get rid of this real quick. Okay, so let's say that the strings array that we're given is something like acts. Well, actually, I think it was just act. Not that it super matters here. We'll just come up with our own list. We go like act, pots, stop, cat, and maybe we'll say hat for the last one. Okay, so again, if we think about this from sort of the naive perspective, what we could do here is we could go through each of these lists and or each of these strings rather, and have some kind of like result list at the end here. And what we could do is we could look through all of the lists in the result and say, hey, are any of you an anagram of the string that I'm currently looking at? So as before, we'll have to look at each string at least once. What is going on in my backyard? One sec, let me close the window. Sweet. Okay, so we'll go through each element of this list, and we can say, hey, go ahead and look at the results list real quick. Do any of those lists have anagrams of the word that I'm currently looking at? Obviously, when we start, there will be no anagrams of that word, so we can go ahead and make a list and put our current string in it. Okay, so now we've put that in its own list, and we can look at our next guy. So we can compare it against any element of this list. If there were multiple elements here, we would already know that they were anagrams of each other, so we don't have to check all of the elements. We can just check any of them, maybe the first one, and basically ask ourselves, like, is this an anagram of this? Okay, we've done the valid anagram problem already, so if you missed that, maybe go take a look at it. But in short, there is a way for us to figure this out. It just might be a little bit, it might take a little bit of time for us to do that. But we would eventually realize, hey, these are not anagrams of each other. If there were more lists, we would go through those as well. And once we exhaust all of the lists that we've created already, we would go, well, I guess this guy is not, or doesn't belong in any of the lists we've seen so far. I guess we'll have to make another list for it. Okay, move on to our next guy. And this time we compare it against act. We realize that's not an anagram. We compare it against pots, and we realize, hopefully, that stop and pots are, in fact, anagrams of each other. And this time, instead of creating a new list, we could just say, hey, actually, I'm going to go ahead and add stop into this list. Okay, and we keep going. Cat is an anagram of act, so we could add it into this list right here. And then hat is not an anagram of anything, but we'll actually take a look at this one just because we have a more fleshed out example now. Once we get to hat, we could look at just this element, so the first element of the first list, and say, well, that's not an anagram of hat. Move on to the next list. Again, we can just compare against the first element of this list and say, hey, you know what, those are not anagrams either. Now that we've exhausted all the lists, we can go ahead and say, well, I guess that means that hat belongs in its own list, and this would be the list that we return. Again, a list with lists inside of it, right? Okay, so where is the weakness of this solution? A few things that are kind of difficult here or are not ideal for us. We've got to look through all of the words, or at least all of the groups of anagrams that we've seen so far to verify that the word we're currently looking at either doesn't belong in a list or does belong in a list, right? That's a lot of comparison to do. Ideally, we would like for there to be some better way for us to record which group a string belongs to. There's actually a couple methods for this, but one method that we covered already for talking about like validating an anagram is sorting the letters of the string. So if we were to do that, so I'll just go ahead and sort of pre-do this, we would get something that looked more like this. Act, and then, oh man, surely I know the letters of the alphabet well enough to do this. I think this one becomes OPST, this one becomes OPST, this one becomes ACT, this one becomes AHT, yeah, something like that, mince. Tell me why we only check the first of the list. Okay, so the only one we need to check, so within each of these sublists, right, we only would have put two strings together if they were anagrams in the first place. So instead of comparing against every element of the list, if we know that the string we're looking at is an anagram of the first element, we're guaranteed that it will also be an anagram of all the following elements, right? So no need for us to compare against everything we've seen so far, just a candidate from each of the lists. The first is arbitrary. We could do the last just as well, and it would be the same thing. So, okay, anyways, if we were to sort these instead, it becomes a lot easier for us to determine if this is an anagram group that we've seen before, right? And in fact, we have a really great way of associating a certain key with a certain value, right? We've talked about a hash map, or in Python, a dictionary. We can reorganize our data, and we'll get a little bit of extra data here, because ultimately we don't want to return these sorted versions. But what we can say is, hey, let's actually go ahead and make a dictionary. And what this dictionary will do is it'll map the sorted version of the string to a list of strings that we've seen before. And we actually haven't done like this particular strategy of having the value be a data structure itself, but hopefully it's pretty straightforward to say, hey, each sorted key is going to map to a list of strings that were in the original array. So in this one, and we won't go through this like in too much detail because we'll talk about how it works out in the code, but this might be something like, hey, act is going to go with, well, act was already sorted, but act from the original array, right? As well as cat from the original array. Remember, what we can do with, or one benefit of using dictionaries or hash maps is that we can check for the presence of a particular key very quickly, right? We don't have to look through all the keys one by one to figure out if we've seen it before. And this is really beneficial to us because, and we'll actually go slightly in order of the array here. For example, when we get to this guy and we know that its sorted version is OPST, we can, in constant time, verify whether or not we've seen that key before. If we have seen it, we throw it in the appropriate list. And if we haven't seen it, it's very easy for us to then make a new key, in this case OPST, and map it to a string that we've encountered, the actual string. So in this case, pots. Right. So similar deal with the next one. We sort this string and say, hey, have we seen the key OPST before? Hey, we have. So in this case, instead of producing a new entry to this dictionary, we just added in right here. Was it stop? Yeah. Okay, and then we would do, for cat, we would say, hey, you know what? We've seen ACT as a sorted key already. Put that in there. For the last guy, we don't see AHT as a key, so we can go ahead and add it. And when we're done here, again, we get a little bit of redundant information, but this is okay. All we need to do is pack all of the values up into a list here and return that list. So nothing too crazy. Now, the question from here is this the best way to produce the keys? We'll go over one alternative method for doing this. But for now, because it's a fairly straightforward solution, this is the one we'll go with. Great. I'm going to switch over to the code editor. If anybody has any questions, please, or comments, please feel free to throw them in the chat, but we'll get coding on this. Okay, so for this method, again, we've got a dictionary. I'm going to call it like a sorted to maybe string list. And again, these curly braces are just how we initialize an empty Python dictionary. Okay, and small like code style thing here. You might initially think for string and strings. We don't want to use keywords as variables, right? So str, I think string is not a Python keyword, but anyways, to avoid this, I'm going to go ahead and say for word in strings, just a little bit less risk of having a weird collision there. So for each word in strings, what we're going to do is we're going to say something like, hey, and it actually sorted itself is also a keyword. So maybe I'll say sorted string equals, and we can actually just do this sorted word. And so what this will do is it'll rearrange the characters of that word so that they're just in alphabetical order with each other. And then we can say, hey, if sorted to string list, or really what we want to check is if this key, sorted string, is in sorted to string list, then what we can do is go ahead and get the list that it's associated with. So sorted to string list with that key. The Python syntax for adding something to the end of the list is append, and we just want to append that word. We're going, hey, I know which list this belongs with. Go ahead and add this word to that list. And if we don't find it, then we can go ahead and make a list. And so I'll just say a list with that word in it, and that's the whole list currently, because we didn't find any others that it was meant to be grouped with. Okay, so what this should do, and I'll just go ahead and print it so we can see what this looks like, is it should produce a dictionary where we have as the keys the sorted strings, and then as the values a list of the strings that belong in that group. So I'm going to go ahead and print sorted to string list here. And then I'm pretty sure this is like a complete solution, so I'm also just going to go ahead and return Oh, now this is actually interesting. There's a few ways that we can convert the values here to a list of lists. I'm going to use what's called a list comprehension. And so what this does is it takes like a data structure of any sort, and it goes through each of the items in that data structure and lets us decide whether or not we want to include it in a list, basically. So here's what the syntax for that looks like. We could say like return word list for word list in sorted to string list dot values. So this let's go through this actually from right to left here. This guy right here gets us just the values of the dictionary. So we don't need the keys. Again, that's just additional information we were using to organize. So it says for each of the word lists in those values included in the list. So we don't have additional like logic for saying like whether or not we should include it, because we just want to include all of them, but this is one way we can convert it here. So we'll both print it and run it here. Now what have I done wrong here? Oh, right, my bad. Sorted actually produces a list here. We can do, well, we have a few options. We could either do this to say, hey, go ahead and turn that list of characters that's sorted into a string. Or alternatively, we can do, hey, go ahead and join together that list with the empty string. So basically just put all those letters together into one big string. What it was complaining about here was, hey, lists actually can't be the keys of dictionaries. So that's what that issue is about. But you can see it works here. And then just so that we can kind of get the information visualized here, you can see again, we've got the sorted string as a key, and the value is the strings that are anagrams of that sorted key, right? This is pretty much exactly what we produced earlier, actually. Yeah. And then let's just talk about a couple optimizations. So she works, thank God. Couple things that we can do here. I wanted to share about a data structure that I like, that I think is pretty acceptable as far as like using in an interview. This is like, we do have to import it, but it is a standard Python data structure. From collections, we're going to go ahead and import default dict. And what this lets us do is it lets us make something that is pretty identical to a dictionary, but it lets us say, hey, the values are going to be something standard. In this case, we're going to say, hey, the values, if there's nothing there, assume that it's supposed to be an empty list. And so this lets us kind of nicely simplify this part right here. We don't have to check if there's already a list there. We can just say sorted to string list, sorted string dot append. I guess we already had this line written, but yeah. So using the default dict basically lets us say, like, if there's not something there already, go ahead and assume that it should be an empty list and then add something to the end of it in this case. We obviously don't need to print, so this works here. And then just in terms of keeping things, like not making new variables that we aren't going to use other than in one place, instead of doing this thing where we like sort it and then use that sorted thing, we could just, well, let me copy and paste this. We could just take this, put it in here. This is starting to get a little bit wordy, but you know, it works. All right, so let's just make sure that runs once again, because I be messing stuff up. Yep, she's good. Okay, and then let's see how much time we've got. We got about 10 minutes to discuss just one other solution that we can use instead of the sorting thing here. Remember, sorting is O of n log n, right? If we can get down to O of n, we prefer that generally. So here's another way that we can do it. Instead of using the sorted string as the key for that dictionary, one thing we can do is we can say, well, effectively something like this. We got 26 letters in the lowercase English alphabet, right? What we can do, let me think about what I want to call this variable. I think Ivy has been calling them heat map. We'll say heat map. And here's, I'm going to write the syntax and then explain it a little bit. What this syntax here does is it makes a list of 26 entries that all start as 0. Hey, welcome in. I think some people just hopped in here. We are looking at group anagrams. We went over one solution that I think is already posted in some of the text threads, and we're going over an alternative here. Yeah. So this other approach involves creating what we might call a heat map. And basically, this is just keeping account of how many times each letter shows up. So obviously, before we've looked at the string, we'll say start all the counts at 0, and it's 26 counts. And then what we can do is we can say, hey, for each, in fact, let me erase this real quick. So for each letter in the word, what we want to do is, so what's the word I'm looking for? Increment the count that is sitting at like the appropriate letter space. So like A would be the first letter, B would be the second letter, right? And one quick way that we can calculate that is we can say this ord letter minus ord A. And basically this is asking us like how many letters away from lowercase a are we? Okay, if it is lowercase a, then those two things are going to be the same, and a number minus itself will just be 0. And what this gets us is what we might call like the letter index. Okay, so once we have the letter index, what we can do is we can say, hey, go ahead and take whatever was at that letter index before and add 1 to it. Okay, and so this is going to produce another type of key that we can use. Notice that we didn't have to sort anything. We just looked through all the letters once. We produce this heat map, and then we're going to do something similar to what we did before. I'm going to rename this. We'll say maybe like heat map to string list. Okay, and this time we can say heat map to string list. Ooh. Now, well, I'll type it in here and then we'll talk about what we need to change here. Something like this. Okay, and then I'm going to change this just so that I don't forget. Heat map to string list.values. Okay, so here's the one problem with what we got here. Heat map itself is a list, and like I mentioned earlier, we actually saw an error about this. You can't use lists, or really what it is you can't use non-hashable things, which includes lists, as the keys of a dictionary. So we've got to find some alternative. There's a few options here. You can use this tuple casting to turn the list into a tuple, which makes it non-modifiable, but that's totally fine because we're done with it until the next word. So we can do something like this. Well, actually, we don't even need an extra line for it. We can just say this. Alternatively, we can do what we did earlier, and we can say, hey, go ahead and join together the elements of that list into a string. So those could be the keys as well. This would basically go where this tuple section is, but either way, this should do what we want it to do, and this makes it so that we don't have to sort the words. If the words are really, really long, like an individual word, like they said here, can be up to 100 letters. That's actually not super long, so it's not a huge deal here. But if the constraints of this problem said, hey, the words can be 1,000,000 letters long, we would really not want to sort the words as we go. We would rather just look at all the letters once, produce this heat map, and then use that as the key. Let's just make sure this works once again. I'd be messing stuff up. Okay, but it worked. So yeah, all that syntax was good, it seems. So this is gonna take a little bit more space, right? Because we've got to use this heat map. We've got to produce this heat map. But it runs faster when the words are longer. So yeah, I think that's all I got for you guys today. Questions, comments, death threats, perhaps? Did not know the heat map strat. Yeah, this is well, I suppose I should say the heat map strat is nice, one, because it lets us produce that well, yeah, effectively that dictionary. without needing a bunch of extra space. But when it's particularly useful to us is when we know we have like a limited number of values. In this case, the 26 letters of the lowercase English alphabet. Can be a great one to use. There's other ways to implement this heat map as well that are even more efficient. So somebody I think recently posted about using like an integer bit mask, which is effectively this, but just with bits instead. Takes up less space. That I think is, well, actually, no, I take it back. That one's not applicable here because in this case, we can have potentially like many of a single letter. Before, we just wanted to know, I think, like whether or not that letter was present. I can't remember. That might be one to review. Anyways, there are definitely alternative implementations, but the concept stays the same. Just how you record the information can become more or less efficient. Is there more I want to say here? No. That's kind of it. I guess the one other optimization we can make here is, again, I put this into a variable just to immediately use it and never reference it again. So with one-offs like that, it's probably better to just say, let me go ahead and make the calculation and put it where it needs to go. So just from like a, let's not name variables when they get used once and never again, let's just use their values, unless they're like especially wordy, and this one's not, so this one works. Yeah. So yeah, pretty much right on time there. Anybody got any last questions or criticisms, perhaps? Awesome possum. I agree with you there. I do love possums. Great, we'll call it there, guys. If you haven't already dropped a solution in the text thread, would love to see your solution there. I mean, you've got one in front of you, so hopefully it makes sense if you haven't posted one. And then just as a reminder, because some of y'all have been coming every day, we will not have any sessions over the weekend. So tomorrow, Saturday, Sunday, we'll be enjoying our weekends, hopefully some of us, and then we'll be back to it on Monday. And then if you're tracking with the upcoming general body meetings, no Fridays. Yeah, I mean, enjoy your Fridays, please. I hope you do. If you're tracking with the general body meetings, we are going to have one on Tuesday. We said it would be in person, but ASI hates us and we're not going to have a physical space for it. So we're going to be on Discord for that. We'll hopefully have some fun activities planned for you guys. We'll have more information about that shortly, but yeah, we'll see you next Monday.